Welcome to Ask and Learn.
Hello. In the question we have given that a plasma is a gas of ionized charged particles. So when plasma is in motion, magnetic effects squeeze its volume. So we have given consider a cylindrical tube of plasma. So over here we have this cylindrical tube of plasma. So it is only mentioned that it has some radius r, but we will consider that this cylinder has some radius r, and the length of the cylinder is, let's say, L, capital L for instance, and it is moving with a velocity v along its axis. So this charged ions, these are moving along the axis of this cylinder with a velocity v. So if there are n number of ions per unit volume, so over here we have given n is equals to n number of ions per unit volume is given to us. So and each ion has a charge q, so we can determine the pressure felt by the walls. So we have to determine the force that is exerted on this walls of the. So now in order to calculate the force that is exerted on the walls of this cylinder, we will first consider, now this plasma is moving with some velocity v. So if it is moving with some velocity, so it is generating some current and it induces a magnetic field. So now taking that into account, so what we do is, so magnetic field in the element, now we will take one small element in the cylinder from the cylinder, and what we do is, so we we will find out what is the magnetic field. So magnetic field dB will be equal to mu naught divided by 4 pi into nq by r square, and v also will be there. nqv represents a current. So now over here we, sorry, we have miswritten this. So n is number of, so we can write this number. Now how many number of ions is passing through this small elemental volume dv. So this n will be equal to capital N divided by dv. So from here number of ions will be equal to n times dv. So now we can just take this, and dB will be equal to mu naught divided by 4 pi into q times v divided by, let us consider that this element is at a distance x square into n times dv. So this dv is, now this is a cylinder, so this will be, so this will be 2 pi x into dx. So this one of the x get cancelled, so dB from here we get it as mu naught divided by 4 pi. So actually this also gets cancelled, and we get mu naught upon 2, and this will be q times v into dx upon x. Now if we integrate this with proper limits, so we will get b. So if we integrate from 0 to b, and from here if we integrate over the entire radius, So like from 0 to r if we do, so we get B is equals to mu naught divided by 2 into Q times V into ln of r. So this is the equation which we obtain. So there is a L missing over here. So over here we have missed out a L. So this volume, inside the volume, so 2 pi x dx into L. So that will give us the entire volume. This will give the area, and multiplied by the entire length will give us the volume. So L is missing. So let us plug it over here. So over here, so this is magnetic field. Now the force due to the magnetic field is given by Q times VB. So now if we plug the value, so we will get the result. So F will be equal to Q V, and B is mu naught L Q V by 2 ln of R. So from here this force turns out to be Q square V square mu naught L divided by 2 ln of R. So with this we complete our solution. I hope you find the solution useful. Thank you.